Okay, so let's try to find that. So here the likelihood function is basically LP. So the likelihood function will be, so we know that this is a boundary random variable. So only, obviously we have only one observation. So it will be like p to the power x 1 minus p to the power 1 minus x. Okay, and where x can take the value 0 and 1. Okay, now here so here we can define, let's say, p or by theta. So it is given like theta, so you can define also p. So where this p is exactly equal to theta and our p is in between half to 1. Okay, so now if we take the ln of L theta, so let's say this is by L theta, ln of L theta will be x into ln p, or let's say ln theta plus 1 minus x into ln 1 minus theta. So that's a simple understanding. Now let's take the derivative. So if we take the derivative, so let's define this by small l theta. Okay, so ln of capital L theta is just small l theta. So then L dash theta, that means the derivative with respect to theta will be x by theta minus 1 minus x by 1 minus theta. Okay, now we have to check this is greater than or less than 0 or not. So to get the maximum value of this L theta. Okay, so this will be greater than 0 or less than 0 if x by theta greater than or less than 1 minus x by 1 by theta. Okay, now if we simplify the part, then we can get theta less than or greater than x. So here we get, so let's say theta equal to x. Okay, so L dash theta is greater than 0, that means increasing when theta less than x, that means it is increasing when theta less than x, and is less than 0 when theta greater than x, that means it is decreasing when theta greater than x. So if in option, let's say if in option it is given that x is the MLE, so if this happens, like in option it is given that x is the MLE, so most of the common person or most of the common student do that this x is MLE. As you can see from this part, that at theta equal to x we can get the maximum value, so x is MLE. But this is not true. Okay, and why this is not true? So we get L dash theta which is greater than 0. So this L dash theta is greater than 0 for theta less than x. Okay, and obviously for increasing case, and L dash theta less than 0 for theta greater than x. And this both implies that, so maximum can be at theta equal to small x. Okay, now let's define two cases. So obviously this theta equal to x, that means this x will be MLE if the theta belongs to 0 to 1. So if it is given that in the question that theta belongs to 0 to 1, then this x will be MLE, and that's true. But here the theta belongs to half to 1, so that's why this x cannot be the MLE. So we have to consider two conditions. So let's say this is my case 1. So first condition, so let's say this is the value of p and this is LP. Okay, and we know that so it's like, so this type of curve. Okay, and so the function is maximum at x equal to, so p equal to, or you can say like theta equal to, so this is my theta. Okay, so theta equal to x, so it is maximum at theta equal to x. Okay, so why this is case 1 and case 2? So obviously some difference between them, and the difference is, let's say this x is smaller than half, that means let's say this is my half point and this is my 1 point. Okay, so if x is smaller than half, then the graph will be like this, and if x is in between half to 1, so then let's say this is my 1 and this is my half. So these are basically the two cases. Okay, now we know that theta is defined in between half to 1. Okay, so theta can take the value x if x is in between half to 1. Okay, so in this region, that means in half to 1 region, theta is defined. So theta is defined in this region, and obviously in this second case, this L dash theta is greater than 0. That means this L dash theta is maximum or increasing for theta less than x. So we know that L dash theta is greater than 0 for theta less than x, and L dash theta is less than 0 for theta greater than x. So this is basically true. Now if half is less than x, that means this situation. So if half is less than x, then so always we have to think about that region where theta is defined. So in the first case, we can see that we can get the value of x where the L theta is maximum, but in this region, that means below half, theta is not defined. So that's why we cannot take the maximum value as x or the maximum point as x point. But from this case 2, we can say it, let's say at x equal to, or let's say at theta equal to x, we can get the maximum value of L theta, and that's a defined value. So for the second case, that means if x is greater than half, that means this case, we can say theta equal to x is the maximum value of this quantity. So if half less than x, then L theta is maximized at theta equal to x. But if x, let's say less than half, that means you can say half is greater than x, then we cannot take the value of x, as theta cannot take the value x, as x is less than half and theta is defined in the region half to 1. So theta cannot take the value x. So what will happen for the case 1? So for case 2, we get the maximum value at theta equal to x. But what will happen for the case 1? So for case 1, we just have to concentrate on this region only. That means only on this region. And we have to check on this region when L theta is maximum. Now, if we see on this region, L theta is maximum at theta equal to half. You can see that, okay? So if let's say half greater than x, that means for the first case, then L theta is maximized at theta equal to half. Okay, so that's why hence theta hat or the MLE of theta is the maximum of half or x. Okay, so you can see from this part. So if half is the smaller value and x is the larger value, then x will be the MLE. And if half is the larger value, x is the smaller value, then half will be the MLE. That means maximum among these half and x will be the MLE under these two cases. Okay. Now this maximum of half and x can be represented in another form. So obviously in MCQ question, it can also be written like maximum of half and x. Okay, but we know a formula, but we will work only with this maximum formula. So here we have maximum of half and x. So if we, let's say, place the formula, then maximum of half and x. Now we know that capital X can take only the values 0 and 1. Okay, so here capital X can take the values 0 or 1. Okay, so maximum of half and x will be half into x plus y. That means let's say x plus half plus x minus y. That means half minus x, or you can say like x minus half. So as we have modulus, so half minus x and x minus half will be same. Okay, now we know that x is 0 or 1. Okay, so that's why modulus of half minus x can take only two values, which is half minus 0 or half minus 1. Okay, now half minus 0 is half and half minus 1 is also half, as we have the modulus. Okay, so this modulus of half minus x is always half, as x takes the value 0 or 1. So this is just half, then x plus half, and which is nothing but x plus 1 by 2.